Hello everyone, my name is Hailee Anderson, and today I'll be talking to you about my project, Profiling Major Craft Beer Components, a high-resolution view for innovating brewing and quality control. So despite using the same basic ingredients for brewing, there is a wide variation in color and flavor between different beer styles, suggesting that there are differences on their chemical level. In this study, we investigated two major classes of compounds that are responsible for beer flavor as potentially discerning features between 5 different beer styles. So the two classes of compounds we're going to look at are isoalpha acids and phenolic compounds. So to perform this study, we obtained 32 beers covering 5 different styles, which were degassed by sonication and then diluted to 50% with water. So the styles that we looked at are IPAs, blondes, stouts, wheats, and sours. After sample prep, we ran these beers on a liquid chromatography quadrupole time of flight mass spectrometer, or LC-QTOF-MS. And this instrument has high resolution and mass accuracy, which allows us to perform both targeted and untargeted analysis. The resulting chromatograms from our beers looked like this, figure 1A. So this is a scan of a stout beer, and you can see that it is very messy. Beer is a complex matrix that contains a lot of compounds, which causes a scan to have many co-eluting peaks. So in order to look at our targeted compounds, we use multiple reaction monitoring or MRMs, which are these small peaks beneath it. So using MRMs increases the sensitivity for your targeted analytes and reduces the interferences from your sample. So after optimizing our method, we ran our standards, which can be seen here in figure 1B, and it allowed us to get good separation of our standards. So from there, we ran all of our beer samples and then quantitated the phenolic compounds and averaged them between each style. So some of the results we got from that are shown here in figure 2. So if we look at the IPAs, which are represented by the green color, we can see that they are highest in catechin, cinnamic acid, and quercetin. So the combination of these 3 phenolic compounds in high amounts could show us that we have an IPA as opposed to a different style. Another result we see is that vanillin was only found in stout beers. So vanillin is a flavor component of roasted barley malts, which are used to brew darker beers such as stouts. And finally, we see that chlorogenic acid was highest in sour beers. So when we looked at the individual sours, we saw that 2 of them had high amounts of chlorogenic acid. When we looked at the ingredients for these 2 beers, we saw that they were brewed with cherries and raspberries, both of which have high amounts of chlorogenic acid. So we were able to tie this result back to the brewing ingredients. We performed a similar study for the isoalpha acids and found that the IPAs consistently had the highest amount of isoalpha acids, while sours consistently had the lowest. This can also be tied back to the brewing ingredients because isoalpha acids originate from the hops, and IPAs are brewed with the highest amounts of hops, while the sours are brewed with the lowest amounts of hops. So after performing our targeted analysis on the phenols and the isoalpha acids, we performed untargeted analysis called principal component analysis, or PCA. So this is a data analysis technique that can be used to visualize the similarities or differences within a data set. So if we look here at the PCA, we can see that the IPAs and the stouts were the easiest to distinguish from the other styles. And we know this because of how tightly the data set is clustered and how they are further removed from the rest of the styles. On the other hand, the sour beers are the most spread out data set, which means that the sours were the most diverse style that we looked at. So this PCA shows that these styles could be distinguished from each other based solely on their chemical content without having any sort of physical analysis. So with that, I would like to thank you all for coming to my poster presentation. And if you have any questions, please leave them in the comments. Thank you so much and have a great day.